Alright, so we're looking at question 13 on the Mac 1140 final exam review. It's asking us to solve the polynomial inequality and express the solution set in interval notation. We're given the polynomial equality 2x squared times x minus 5 times x plus 6 times x minus 1 squared is greater than or equal to 0. So our first step for this is to take each term and set it greater than or equal to 0. So let's go ahead and write that out. So now that we have it written out, let's go ahead and start with our first term. So we're going to go ahead and divide both sides by 2 to isolate our x, which will get us x squared is greater than or equal to 0. Now we have to square root each side to get rid of the square in the exponent spot. That will leave us with x is greater than or equal to 0. Now for our second term, super easy. We just have to add 5 to both sides to isolate our x, which leaves us with x is greater than or equal to 5. For our third term, again, super easy, subtract 6 from both sides, which leaves with x is greater than or equal to negative 6. Lastly, our fourth term, we need to square both sides to again get rid of that 2 in the exponent spot, which will open up our parentheses set to give us x minus 1 is greater than or equal to 0. Add 1 to both sides. That leaves us with x is greater than or equal to positive 1. So now that we have all our numbers, let's go ahead and draw out a number line. When we draw that out, let's go ahead and label it. We're going to have negative infinity to positive infinity. We're going to have negative 6, 0, 1, and 5. Now let's go ahead and choose numbers in between each little set. So between negative infinity of negative 6, negative 7, between negative 6 and 0, negative 1, between 0 and 1, 0.5, between 1 and 5, I'll just choose 2, and 5 to infinity, I'll choose 6. So now that we have our numbers we need to work with, we're going to test if these numbers give us a true statement in between their given sets. So let's go and start with x is equal to negative 7. All we would do is plug in negative 7 into every x in our original polynomial inequality. When we do that, we're going to have 2 times negative 7 squared, negative 7 minus 5, negative 7 plus 6, and then negative 7 minus 1 squared is greater than or equal to 0. Now when we simplify this, we're going to get 2 times 49 times negative 12 times negative 1. This is going to be positive 64 is greater than or equal to 0. So you can simplify this a little further. I'm just going to simplify this term set right here. So we'd have 2 times 49 times positive 12 times 64. And just from simplifying that, we can see that we have all positive terms multiplying by each other. So since we know it's all positive, we know that we're going to get a positive number is greater than or equal to 0. So just off of that, we know that this creates a true statement. But if you want to go ahead and multiply out all the numbers, you would be left with 75,264 is greater than or equal to 0, which is again true. So let's go ahead and label that. For this region, it is true. Now we're going to follow the same exact steps for x is equal to negative 1. So same thing, 2 times negative 1, negative 1 minus 5, negative 1 plus 6, negative 1 minus 1 squared is greater than or equal to 0. 2 times 1 times negative 6 times positive 5 times negative 2, 4 is greater than or equal to 0. So using the same method we did last time, you can see that we have a positive times a negative, positive is greater than or equal to 0. So based off the fact that we have one negative present, we know that a negative number times any positive number is going to give us a negative number. So we know that this is going to give us negative some number is greater than or equal to 0, which we already know is a false statement. But for the sake of math, let's go ahead and multiply those numbers, and you'll be getting negative 240 is greater than or equal to 0, which is again false. So let's write that up here so we know that region is false. So again, same steps for x is equal to 0.5. Let's plug it into all of our x values. Now let's simplify it. Now that we have it simplified, we can see again that we're running into the same issue where we have one negative number and the rest are positive. So because we have one negative times a bunch of positive numbers, we know that we're going to be left with a negative number is greater than or equal to 0. Again, if you multiply them all out, you'll be left with approximately negative 3.66 is greater than or equal to 0, which produces a false statement. So we know that this set is also false. So again, doing this for x is equal to 2, plug it in. Once we have it completely simplified and reduced, we can again see that we are left with 1 negative times the remainders are positive. So when we have that situation, just like the last ones, we know that we're left with a negative answer is greater than or equal to 0, which is false. And when you do out the math, you'll be getting negative 192 is greater than 0, which is again false. So let's label that up here. Now we are finally on our last one. So let's go ahead and do x is equal to 6. Let's plug it in where it needs to go. Let's simplify. And looking at this, we have all positives. We have a positive times a positive times a positive times a positive times a positive. We know that when everything is positive, we're going to be getting a positive number is greater than or equal to 0, which is true. So let's multiply everything out to verify it. And we should be getting 21,600 is greater than or equal to 0, which is true. That's very true. So when we label that up here, we can now look at our number line. So looking at our number line, we can see that we have a true statement from negative infinity to negative 6. We have a true statement from 5 to positive infinity. So when we write that out in interval notation, we know that we're going to have a parenthesis for negative infinity, because infinity always has a parenthesis. And then for negative 6, we're going to have a bracket because we have that greater than or equal to symbol. And then we're going to have a union since we have a second term. And then 5 to positive infinity. My infinity looks kind of messed up, but that's your final answer. And again, that was doing that reading from left to right on our number line.